We have this loop where we have an inductor here, magnetic field is inside the plane, and this rod is initially given a velocity v0. We need to find x as a function of time of this rod. So initially, let's say this x is 0. So initially the rod was here and velocity was v0. Later, at a general x, let's say the velocity is v. Now we know if a rod is moving with a velocity v and magnetic field is perpendicular to that, the induced EMF will be BVL, and because of that, current will start to flow in the loop. So then what happens, because the current is flowing, this rod will experience a force, and that will be I into L cross B, so that will be towards left, opposite to the direction of V. So that is what is happening. So first let's find what will be the value of I, then with BIL we'll find what will be the value of force, restoring force. So let's start. So in this loop, BVL minus L di by dt is equal to 0 and V is dx by dt. So this gives a relation between x and I. So we do that and we get I is equal to BL by L into x. Now this is the I, so force on this rod will be BIL towards left. And we have considered right side as positive. So let's say acceleration is A towards right. So restoring force on rod MA is equal to BIL. So I'm saying restoring force, so I'm not writing any signs here. Both sides, let's say, are positive. So A is, so we put the value of I here and we get acceleration to be proportional to x. Proportionality constant is omega square. So that means the rod is performing SHM, and initially when it was given V0, here that was the mean position. So at t is equal to 0, the rod was here and then it was going towards right with velocity v0. So for this, our equation of SHM is A sin omega t. So omega is this, and amplitude we can get from v0 at mean position. The rod velocity was v0, so that is equal to omega A. So this gives A is equal to v0 by omega. So if you just put the value of omega here from this will be our answer. All right.